Okay, so again, we wanted to thank everyone for spending the time and coming for our webinar today, logging on for our webinar, the crack injection KOSTER systems for all different kinds of cracks and repair. Again, I'm Matt Sorensen, the technical specialist with KOSTER, and we're glad that you guys took the time to spend with us here today. There are a couple of factors that go into the process of crack repair. The first is primarily why are we repairing these cracks? There's two basic sides to that. Is either obviously just aesthetic. So we're having an aesthetic issue with cracking in a facade or the outside of a structure potentially. Primarily, what we're looking at is going to be a loss of functionality. So lost capacity, lower loss, low capacity. Also coming into this in terms of lost capacity is leaking cracks. So cracks that are leaking water and are under heavy water ingress are primarily what we're going to be dealing with here in terms of the capacity of a space is lost because of leaking cracks and leaking water. Another reason why we would take care to repair any kind of cracks in our concrete substrate are for functionality. So like we said, for water tightness, for leakages of water, but also air tightness, having to do with carbonation and passivation of steel reinforcement in concrete. So carbonation occurs obviously from the surface down of a concrete substrate when it's exposed to air. But carbonation is where through these cracks, this carbon dioxide enters the construction member. Because of that exposure to the carbonation and the CO2, the passivation, which is provided by the high pH moisture, high pH solution in the concrete that prevents the reinforcement being corroded, that is nullified or canceled out by that CO2, and that steel can be corroded. As water and oxygen enter the member, they come in contact with the steel reinforcement, which obviously causes that to corrode, which can expand and cause spalling and blowouts of concrete, as well as loss of functionality and obviously severe damage of the member, not only aesthetically but functionally. Where if we lose reinforcement and lose spalls and blowouts of concrete, we lose obviously strength and functionality of that construction member. Also, we would like to try to isolate what the cause of the crack is, whether it's from dilatation or expansion, creeping or shrinking of the substrate, settling of the ground or settling of the building into the ground, movement of buildings against one another, or more severe circumstances like earthquakes or potentially floods that can cause buildings to heave or to settle. So finding out the cause of the crack kind of gives us a better idea of how we want to treat it, whether it needs to be an elastic treatment or rigid treatment, so on and so forth, and what the purpose of our injection should be. Getting some more information about the crack. Again, like we talked about, what kind of crack is it? What is it caused by? What is the course and width of the crack? Is the crack moving, not only separating the but other flanks relative to each other? Is one side becoming more elevated than another, either in horizontal or vertical cracks, where we're seeing those two sides of the crack are not in plane, where we're definitely dealing with some settlement or movement of some kind. Again, how much movement is occurring? When does the movement take place? Is this based on like a frost heave, or is this based on weather or any kind of other circumstance? When does that take place? And primarily what we're dealing with again here is it water bearing? Water bearing. Is this crack going to allow water ingress or bear water and cause issues in that regard? Again, it's gathering information, dealing with the cause of the crack. Is it a crack like this pictures that's either a shear crack or from some kind of a flexural issue, lack of reinforcement or something like that in a construction member? These are construction members that are cracked that have obviously lost their functionality, where it's important to use some kind of rebonding agent to restore their physical strength, or at some circumstances it's not possible to gain that functionality back. Again, looking at the course of the crack.
Seems to be typical of all that America used to stand for. A beacon of hope.
Sorry, guys. Again, crack repair, gathering more information about the crack. What is the course of the crack? How does it travel? Primarily vertically, horizontally, and where is the origin of the crack, as well as the width of the crack. Primarily, these are used to identify how we're going to treat this crack. Width primarily about how we're going to treat it, but the course of the crack can also tell us a good deal about how it was caused and where that origin was. We're also looking for the condition of the crack and its flanks. Again, whether the crack is a simple crack in the concrete or the flanks have been broken down by other factors. Is it water bearing? And again, have those flanks moved independent of one another? And finally, any kind of previous measures that have been taken to try to seal the cracks, whether it's been an injection of some sort, some kind of surface seal, or any kind of other measure to seal the crack. If that has been attempted before, that's a good kind of informational piece for us to have in terms of what has previously been done to try to seal this crack. Again, gathering information about movement of the crack, whether it's short-term movement or long-term over the period of the life of the building, whether it's a very long-term issue or it's relatively short-term. And again, settlement and shrinkage cracks. These are primarily most popular, or not most popular, most common kind of cracks that we see, not only horizontally but vertically as well, are normally shrinkage cracks or settlement of the structure over its time. Again, here we have kind of dry cracks and wet cracks. The dry crack on the left looks like a settlement crack of some sort, or a crack caused by impact, where on the right we're looking at a water-bearing crack. Again, you can see that bubbling water. This is certainly allowing a lot of water ingress. This is obviously a high pressure crack that's obviously experienced a lot of penetration of water. But if we determine what the moisture condition is, whether there's moisture present, and whether that's a pressureless injection that maybe trickles and leaks occasionally, or a crack that's under pressure that requires immediate repair because it does leak very, very heavily, like as we can see in this picture here. So coming up with a plan, a method to treat and seal and remove any issues we have with the crack, it's important to know what our objectives are and what we're trying to do. So trying to just seal a crack from the surface that's not necessarily moving, that's not water bearing. Normally that doesn't require an injection. We can install like a surface seal. We can do that injection from the surface. To waterproof the crack, injections required to get into the crack with some injection port of sorts, and use a foaming injection, foaming resin or a solid body resin to seal that crack, to restore structural strength as well as flexibility and flexible bond in a construction member. Those require injection as well to provide that, again, structural repair and structural rebonding and flexibility. First, for sealing cracks from the surface, potentially just horizontal cracks in a concrete slab that are not necessarily water bearing. We can do this by saturation, by filling cracks and voids without pressure, almost gravity feeding from the surface. This is one case. The second case, in the case of waterproofing cracks, the injection will fill cracks or any voids that are under pressure via packers or injection ports. This is the primary purpose that these injection products serve, for waterproofing leaking cracks. Finally, for structural repair, restoring structural strength and flexible bond, the crack must be filled 100% with some kind of repair material, and can't just be gravity-fed or surface sealed. We have to make sure that crack is 100% filled so that it restores the physical properties that we're looking for with that construction member. So here's some information about our different kinds of water stopping systems. The base materials for injection, that are common in the field and that we certainly offer are, first, there are cementitious injection grouts that are used primarily for filling voids and some structural rebonding. Primarily filling voids is their kind of go-to. Polyurethanes can be used in much more applications. They're probably the most versatile. They can be used for filling voids, for structural rebonding, for foaming water stop resin products, solid body elastic resins, and also for soil stabilization. When we use these, we think of these polyurethane injection products, specifically the foaming injection products. Soil stabilization they can be used for, but they really don't have a very low viscosity. So they aren't great at soil stabilization like some other products we'll talk about later on. But it's certainly with filling voids as well. The foaming action's a sometimes more economic option to fill voids and other areas like that, just because of the high foaming capacity of these products. Epoxies are used mostly for filling voids and for structural repair and structural rebonding. And injection gels are mostly used for low viscosity. They can be used for soil stabilization. They're definitely elastic solid body products and can be used for filling voids as well. We had a presentation last week on some of our injection gels, and we'll probably be doing that one again shortly. But the gels are more of a systems approach where we're installing a barrier along the backside of the wall rather than isolating and filling voids just by their injection. So here's a list of our polyurethane injection products. We do have a line of 7 polyurethane injection products: the Ion 1, 2, 3, 4, 5, and 7, as well as the KOSTER 2-in-1. KOSTER 2-in-1 is a hybrid product that combines kind of the performance of different kinds of polyurethane injection products, and we'll see that as we go through here. So polyurethane injection materials, especially our products, but as a rule, the polyurethane injection products are one of two kinds. Either they react with water and foam as water stopping or void filling materials, or they react without water and form either a rigid or elastic solid body resin that we can use for structural rebonding or applications like that. Also, these foams are not very long-term chemically resistant, and they do break down over time. So the solid body resins do last much longer, and they have a little more body to them, we'll say. So the systems for water stopping with our injection products, there's 3 of them here. One of them is to inject with the Ion 1 to stop the active leaks, and post-inject with Ion 2 to encapsulate that. The next is the KOSTER 2-in-1, which is a hybrid product. We're going to get into each step-by-step of these. Finally, we have the KOSTER Ion 7. And here's the circumstances when we're dealing with high-pressure water-bearing cracks. The Ion 1 and the Ion 7 are much faster reacting and more expansive to stop heavy active leaks. The 2-in-1 is still foaming and still heavily reacting, but with a little bit lower reaction time. So it does, if we're dealing with very, very heavy water ingress, we usually go with the Ion 1 or specifically the Ion 7. The first system here, with the KOSTER Ion 1, again, this is a rigid foam. Both these products are tested and certified for use in drinking water environments, but the Ion 1 is a very expansive, rigid polyurethane foam that starts reacting about 30 seconds after it encounters water, expands for about a minute or more, depending on the agitation. Like we said, these foams don't have a very, very long lifespan in terms of breaking down either from movement or from just normal conditions. So what we would do is we would re-inject with the KOSTER Ion 2, which is an elastic solid body resin with a fairly low viscosity of 200 centipoise. The Ion 2 is post-injected into the same ports and encapsulates this foam to prevent that foam from breaking down. The problem is you have to use 2 materials here to come up to provide a good long-lasting repair. We'll talk about later where we have an option system with obviously one product that can kind of do it all. The other kind of product, again, for heavily burdened under pressure cracks is the KOSTER Ion 7. This is more of an elastic, forms more of an elastic foam, again with the faster reaction time, and it expands about 30 times the original volume to foam and react and fill voids and stop leaks. So this is obviously the product that you're going to use in heavy leaking environments with lots of water ingress. But again, the foams do not have that guarantee of long-lasting performance. This is where we come to the KOSTER 2-in-1. It's a hybrid product. Obviously, we saw the system with the IN1 and the IN2. The KOSTER 2-in-1 is a system that can kind of do it all. So this is a product that when it reacts with water, it forms an elastic foam that expands and kind of fills any voids and works like a normal injection product. When it doesn't react with water, it forms an elastic solid body resin that obviously gives us some of that flexibility and the longer lasting body. This is a product that what we would do is into a water bearing crack, we would inject the KOSTER 2-in-1 to have it expand and react with that water and foam and stop any active leaks within the pot life of the material, probably between 10 to 15 minutes after that first injection. We re-inject the same material into the same ports. After that water has been used in the reaction, the crack should be fairly dry, and they will react as a solid body resin again to encapsulate that foam and give us a long-lasting system with one product where we're injecting the same product twice into the crack without needing to change over and clean the pump between injections. Also, it has an extended pot life, about 45 to 50 minutes, so you can inject the material without having to clean the pump and inject again, depending on the size of the crack, obviously, and the size of the injection scope. But the 2-in-1 is like your all-purpose for any kind of water-bearing crack. Again, in circumstances where we do have really, really heavy water ingress, it may be better to start with a fast reacting or more expansive polyurethane foam. But for most cracks, this is the product that is ideal for not only sealing but permanently waterproofing and permanently sealing the any kind of leaking crack. Okay, so now we're on to elastic crack sealing with the solid body resins. These are products that do not need water as part of the reaction, that react as solid body resins. The KOSTER IN2, the 2-in-1, IN4, and IN5. The KOSTER IN2, we discussed this as part of the original system, but this is a product with a 30-minute pot life, cures to an elastic solid body resin for dry cracks, or permanent crack sealing of dry cracks, and just rebonding of those cracks. 2-in-1, again, we have that right side circled to isolate the elastic solid body resin. When it is injected into a dry crack, it can cure or will cure as an elastic solid body resin for, again, we use this in dry or moist cracks and for permanent sealing of cracks. IN4 is very low viscosity injection resin, with viscosity as low as 30 centipoise, depending on the temperature, for sealing dry cracks, again, for sealing those and giving us an elastic matrix in the injection. Again, longer pot life, so this can be used also with hose injection in construction joints. Finally, we have the IN5 with an even longer pot life, about 4-hour pot life for dry or wet cracks. This is specifically designed for hose injection with its longer pot life and its lower viscosity that allows that to penetrate after the hose injection into all those voids in a construction joint or any kind of joint where that hose has been installed to permanently seal the application. Finally, for restoring structural strength, we have the IN3 as a polyurethane injection foam, or excuse me, as a polyurethane injection product. That's a solid body resin. It cures with a compressive strength of greater than 12,000 psi with great flexural strength and very high tensile strength to either bond of to either flank of the crack or joint that it's injected into, with a fairly low viscosity, about 300 TPS. This is used for dry cracks for structural rebonding. We have also the KBpox IN, which is an epoxy injection product with a very, very low viscosity, really extended pot life and reaction time. This we can use to surface seal or gravity feed cracks. We see this a lot of times in applications with our moisture mitigation system for sealing cracks on horizontal surfaces, but it can also be used for with injection to vertical and overhead cracks, again with a very, very low viscosity and longer reaction time, very high tensile strength, very high bond strength when installed as well. So this is a great product for structural rebonding of construction members as well. The last product here is the microgrout 1C. This is a cementitious injection grout. So we've gone from polyurethane epoxy, now we have cementitious products as well. It's a very, very fine, non-shrinking injection grout for crack filling and for void filling. It has very high compressive strength as it cures almost 9,000 PSI. This is primarily used for fine crack filling and sealing, restoring structural strength, and for void filling in masonry substrates and behind masonry substrates as well. But as opposed to sealing with a foam with a little bit lower compressive strength, as that foam reacts, this can be used for void filling with a very, very high cementitious, very, very high compressive strength cementitious product. The packer systems that we would normally use for crack injection. So we do have impact packers, bang-in packers, where we for lower pressure, for very low pressure injections, where the borehole is drilled, that packer is banged in. These are sometimes called bang-in packers, and then the material is injected into the wall through that. More common than not, we're not dealing with very low pressure injections. So bang-ins are okay to use for low pressure injections, but commonly when we're dealing with injections, we want to deal with something with a little more ability to attach itself to that borehole, so that we don't end up getting an increase in pressure in that packer potentially blowing out of the borehole. Like any, obviously, safe injection works. When we're injecting into any of these ports with any kind of pump, we never want to stand directly behind the packer in case we do get a blowout of the packer. That's just your typical safety measures. More commonly used, we have the KOSTER super packers. They're 10 and 13 millimeters in diameter, and they come in several different lengths. These are much safer and much better to use because we get the additional contact pressure because of that cone-shaped tightening screw. These are installed into your borehole, and the shaft, so the silver part on the left, is tightened, and as it tightens, it expands that green rubber gland that, as we can see in the picture on the right, as that gland swells, you get much more contact with the surface of the borehole, so you're much safer, and you don't have nearly as much risk of a blowout of a packer. Again, we get good grip in the packer in the borehole because of not only the ribbing of the rubber seal, but because of expanding that rubber gland and getting much more contact. After that borehole's drilled, and obviously the packers are placed and tightened after the injection works, they're designed so you can either bang out or loosen that metal shaft on the left of our pictures, and that gland is normally just left inside the wall, and the portholes are sealed over it. We have here kind of an example application of a crack that was injected with the KOSTER 2-in-1. So here we have a crack bearing of a railway bridge. The picture on the right is identifying the crack that we are isolating in the obviously concrete substrate. We're injecting into concrete here. When it's practical and when a crack is greater than potentially 1/8 of an inch or bigger, normally we open the crack either in a V shape, or we route the crack out with an angle grinder and we remove any of those loose particles. This is commonly done when we're surface sealing cracks, when the cracks are surface sealed to prevent injection material from flowing out of the crack. We like to prepare and clean that crack either by routing out with an angle grinder or by mechanically preparing the crack to be sealed. In the picture on the right, we're marking the positions where the holes are going to be drilled. They're obviously placed on alternating sides of the crack in an interval of approximately 4 to 6 inches on center. When we drill these holes, we want to obviously intersect that crack along its path, assuming that the crack goes straight back perpendicularly through the wall. So we drill the portholes on either side of the crack, 1/2 the distance of the wall at a 45-degree angle, so that we can have our best chance of intersecting the crack in the middle of the wall. We have another diagram on that will, if that's tough to visualize, but we do have, what we're trying to do is intersect the crack in the middle of the wall. Oh, here we go. Yep. The diameter of the portholes obviously depends on the packers that are chosen. The holes are drilled towards the crack at an angle of about 45 degrees, And again, we can see that the goal is to intersect the crack about halfway through the wall. So offsetting from the crack either side by half the distance of the wall gives us that geometric estimation to hit the middle of that crack. Again, cracks do not always go directly 90 degrees perpendicular into the wall. So we'll get to that later, but we may run into issues where we drill a porthole and we begin to inject, or while we're drilling, we don't feel the crack, or while we're injecting that we don't end up putting material into the crack, or we realize that we missed that area, and there's certain circumstances we can do to take care of that. After the boreholes are drilled, they're cleaned using pressurized air or water. We've cleaned the front surface of the crack out just to remove any loose dust. The crack is closed along its surface with a mortar like KOSTER KB Fix 5, for example, to prevent injection material from flowing out of the crack during injection. This is where the two different kind of schools of thought come in, where sometimes we surface seal these cracks, especially when they're wired, to prevent the flow of injection material out and to create that high density foam inside the crack. The other side of that coin is how do we monitor the travel of material up the wall. Most times when you inject, obviously from top to bottom, you can monitor the material and the foam by looking at the crack up the surface. If we surface seal, we're very unlikely to see obviously material moving up the crack. So if we do install a surface seal like this, we're going to install the super packers into every other porthole. So we're we're installing these ports in every other porthole. What this does, this gives us a sight class or viewing window. As that foam or gel rises, we can see it coming out adjacent portholes, and we can monitor the flow of material up the wall. Another option is in finer cracks, we can leave that surface not sealed, and we can see the material moving up the wall in that manner. This is really a means and methods kind of choice to make sure that we can monitor the material moving up the wall. And again, there are those two different kinds of schools of thoughts, primarily depending on the width of the crack as well. If the crack is very wide, we're definitely going to need to surface seal it to prevent material from flowing directly out the face of the crack. So when we install the super packers, obviously in this circumstance into every other borehole, push the packer in. You can pre-tighten it by hand, and then obviously use a wrench or a socket wrench to finish tightening that packer. When we're installing these super packers, sometimes they're a little bit hard to get in by hand. They do work with a little ball joint in the tip, so I definitely wouldn't use like a hammer and bang them in right on the surface of the hammer. We can use potentially a rubber mallet, or if you put a long socket from a socket wrench over and bang them in that way, preventing that direct impact with the tip of the packer, especially that ball. Because if that ball gets damaged, it either won't allow injection material to be installed into that port, or it may not close, and after you inject, the injection material may just flow right back out. So we want to make sure we take care when we're installing these that we don't damage the ports before the injection's even begun. We're using 2-in-1 here again, so we thoroughly mix the A and B component in a 1-to-1 ratio using fairly slow mixing procedure. We don't need to mix very intensely, or we certainly don't want to create a lot of heat or add a lot of air into that injection product. Just a simple, very slowly rotating mixer, just until it's homogeneous and free of streaks, maybe for a minute or a minute and a half. KOSTER 2-in-1 in this circumstance is being injected using our single component injection pump, the KOSTER 1C injection pump, which is a very simple, very easy to clean injection pump. And most conventional, most single component injection pumps can be used and modified, and many can be modified for injections like this. But obviously, when a contractor is trying to design a pump, it has to make sure that it's not only functional but safe for him to use. Also, you can buy fairly cheap pumps from any kind of hardware stores, paint sprayers, spray pumps, and modify them to work as one of these pumps, as an injection pump. But if something goes wrong or there's an issue with that pump, there's no way to really repair it. You'd scrap it and get a new one. With the 1C pump, the KOSTER 1C pump, Obviously, it's fairly easy to replace parts, and we do have all kinds of maintenance parts and replacement parts to allow you to repair the pump instead of scrapping it and having to buy a new pump and start from scratch. So we're injecting the 2-in-1 via the super packers into the crack, proceeding from top to bottom, excuse me, from bottom to top. We're working up the crack to allow any kind of injection material that's injected to settle on top of material that's been injected below. So we start at the bottom and work towards the top. When we're injecting 2-in-1 into either a moist crack or a crack that we don't visually see water, it's very common to pre-inject the crack with water or expose that crack to water before the injection process begins to stimulate the foam reaction. This can be done either by exposing it to water on the surface if the surface of the crack is open, or we can take our ports and we can inject water through them using a hand pump or the KOSTER foot pump, or even a one component pump like the 1C pump. It's very important that you have a separate way of injecting the water and the obviously the polyurethane injection foam, so that those two don't cross paths and potentially you get a reaction of the material in the pump or in whatever kind of injecting tool you're using. So again, when we're pre-injecting, we can use the KOSTER hand pump or a foot pump or a similar kind of pneumatic pump or another 1C pump. We're going to get into more of the details and FAQs of the injection a little bit later, but for right now, we'll assume that the injection has been done. The injection is completed. Again, with the 2-in-1, we inject for that foaming reaction. We wait about 15 minutes. We go back and post-inject. We re-inject that same material into the same ports for that solid body resin to form and encapsulate the foam and give us that longer lasting elastic solid body performance. After all the injection works are complete, we clean the pump with a solvent. We use obviously KOSTER Pure Cleaner, or a solvent that's recommended in the operating manual of the pump. The KOSTER Pure Cleaner is a great product for cleaning these machines because it has a blend of solvents with a very high flash point, and it's not harmful to the mechanical components of the pump. Certain other solvents that are used, primarily we see, acetone is one of the more commonly used cleaning agents. This can be very harsh on the seals and the wear parts of the pump. As well, also, acetone has a lower flash point than the Pure Cleaner, so it may be that there's material that's bound or unreacted material that's bound in the acetone, and if that acetone does flash off, that unreacted material may still be left in the pump to react and cause issues. Commonly, after we clean it with the Pure Cleaner or with solvent, we run that through, cycle it, and then we'll store the pump with oil, motor oil, vegetable oil, something like that, to prevent any kind of ingress of water or a reaction of any material which may be left in the pump itself. Like we discussed, we remove any of the packers and we seal the bore holes with KB Fix 5 or KOSTER repair mortar or similar mortar. And if we are injecting a crack where the surface is not sealed and you do get some foam through that surface, that can be scraped or ground off, taken off with a wire wheel, and the surface can be brought flush with, or that surface can be sealed and brought flush with Repair Mortar Plus or KOSTER KB Fix 5. We have kind of some FAQs about the injection process itself. Primarily, the biggest question that we always get is, how long do I have to inject, or how do I know how much material to inject into the crack? So we have kind of three methods of determining how much material you have to inject into the crack. This isn't going to be something that you're going to walk into the project knowing. These are going to be little pointers to help you through the injection process. First is by distribution. So again, if we begin the injection with injection ports in every other porthole, we would inject 2-in-1 into a lower port. It will travel through the crack and come out the open porthole next to that next adjacent empty injection port. Enough material has been injected into the port that you're injecting when 2-in-1 or resin comes out of the neighboring open borehole. As we can see in this picture here on the right, he's injecting into that port on the left of the crack, and we can see up maybe 6 or 8 inches on the other side of the crack, we're getting resin coming out of that adjacent borehole, which means we've had enough travel of the material up the crack and out that borehole, which means that foam has moved far enough up the crack where we can stop, install an injection port in that open porthole, and continue the injection up the wall. Another option is when obviously if we don't seal the surface of that crack, we can monitor the flow of material up the crack from the outside. Again, the second kind of thing that'll help us know that we have enough material in the crack is counterpressure. If counterpressure develops inside the crack, all these pumps will have a pressure gauge on them, and you can always hear the pressure regulator on the pump if counterpressure does develop in the wall. The pressure on the gauge of the injection pump or injection whip will increase, and no more material will end up being injected into that injection port. This can also occur, like we discussed, if we do drill a port and it misses the crack, and we install a packer there and we inject, and there's nowhere for that resin to go as being injected, we'll get that counterpressure, and we'll realize that either we need to seal that porthole or we need to drill another borehole close by to allow us to inject into the crack in that area. But this counterpressure can tell you that there's enough material in there. It's really important to be very knowledgeable or careful about that as well, because injecting too much material, especially with our heavily reacting, heavily expanding ion 1 and ion 7, if you do inject way too much material in there and they do react, this can cause blowouts or spalls or issues in other areas where the concrete may be weak or friable. This severe expansion, severe pressure may cause further issues down the road. So you definitely don't want to over-inject. You want to be very careful about only injecting as much material as needed. Again, primarily with the more heavily reacting ion 1 and ion 7. So if we do get a severe counterpressure built up, we can end the injection in this port and move on to the next injection port. Finally, if foam is injecting or escaping from other places in the crack, that's when we know that we've injected enough material. Yet another frequently occurring sign is enough material has been injected is where resin or foam comes out of the wall somewhere else. Here you can see a small micro crack that's developed off of the crack. If we see foam, this is very common, foam coming out of smaller cracks that might not even be visible to the eye. Now, we know that enough material is reacted and created pressure within the wall that it is escaping out of these smaller cracks out the face of the concrete. This means that the resin we've injected has been pressed into and filled any kind of capillaries or voids in the substrate, and it has found a way to come out on the surface. Now we know we have enough material in there. This is also a sign if you're getting severe expansion like we just discussed, you definitely want to stop if you see foam coming out of the surface of the concrete. And one of the more important things, I know we have a couple of things that we discussed that are important to note and important to talk about in terms of knowledge on the job. Even the most experienced person who's done these injections hundreds and millions of times, you cannot look into the wall. You can't see exactly what's going on in the wall. It must always be taken into consideration, must always be known before the project that even with the best, most diligent application, due to voids or non-homogeneities inside the wall or any other reasons, but within or behind the wall or related to the crack, it may become necessary to re-inject at a later date to make sure that we seal any voids. Especially when we're doing an injection like this into a crack and hoping that it's all the way sealed, where we can't actually see the installation. Obviously, it's not always possible for 100% of the crack to be guaranteed to be filled every time. So, depending on discrepancies within the wall and within the crack, it's not always a guarantee that we seal everything every time. Again, so our website is kosterusa.com. There you can find all of our contact information for our sales and technical team. My information is there in that contact tab as well as specifications, technical information about any of our products, and information about any of our upcoming webinars and seminars. Any of our upcoming webinars can be found by clicking on the products tab and going down to the bottom of that menu where it says either training seminars or training webinars, where we can find all of that information.